So the question is, if you want Quick Drop to be able to drop one of your VIs, what are the restrictions on that? That VI has to be in an open project or in your palettes somewhere in order for it to show up. If it's in either of one of those places, you can still type in select a VI, and it'll bring up a browse, and you can browse to the disk and then drop that from Quick Drop. Select a VI actually is SAV. It's got a shortcut, an object shortcut, so you don't have to type in the whole word, it's just SAV. I've wanted for a while to add a feature that lets you like point to a folder, and Quick Drop will list everything in that folder. Haven't gotten around to doing that yet. I'm the Quick Drop guy, by the way, in case you didn't know. Quick Drop first came out in LabVIEW 8.6. It was alongside block diagram cleanup. That was also a new feature in LabVIEW 8.6. And I guess that was 10 years ago. So we've all had Quick Drop for 10 years, thanks to me. So you're all welcome. All right, what else? Still got a few minutes. So the question is, in LabVIEW NXG, is there going to be something like an X control? An X control being a way to define edit time behavior of a control with G code behind it. There are plans to be able to provide customization like that. As far as the actual X control technology itself, I can tell you with pretty strong certainty that will never migrate over to NXG. But equivalent functionality where you could have a control and have G code define its execution behavior, it's in their backlog of features. Quentin, did you have something to add?
Yeah.
Being Mr. X Control?
Well, I'm not Mr. X Control.
After you see this presentation, you won't want to be known as Mr. X Control.
After you see my presentation, see I'm no longer Mr. X Control.
Yes! I mean, oh, that's so unfortunate. Quentin, I'm sorry to hear that.
So I have a presentation coming up on Thursday. I'm going to introduce something that I call Q controls.
I love it.
That replaces
Because
X
his name is
controls.
Quentin.
Yes, my name is Quentin, or Q. But it has a better likelihood of being able to port to NXG than any of your X controls would. So
Very cool.
So come see that.
Very cool. For those of you just walking in, I have not started the presentation. I'm merely asking the audience for random questions before we get started. Anything else? Here we have one back here.
Is there any chance of getting a by reference object class?
The question is, are we ever going to get by reference objects? So like classes wrapped in DBRs isn't good enough for you, I guess?
I mean, just not have to build it up.
Yeah, so yeah, people want to be able to say, I want this class to be able to be passed by reference instead of by value. I don't know of any active work on a feature for that right now. Question? So the question is, do we have any plans to enhance the tab control? So the tab control, you can statically define the tabs, and LabVIEW is relatively limited. There is an X control available on the tools network called the X tab that adds a lot of functionality to tab control behavior. We, to my knowledge, do not have any plans to extend the tab control in that way at this time in LabVIEW. I honestly don't know what the plans are for LabVIEW and XG.
We'll be able to build X tab.
So again, that relates to, is there going to be a way in NXG to have G code define the edit time behavior of a control? That is on the backlog of features for NXG. I don't know of any timelines. I work primarily on LabVIEW in LabVIEW RandD. I don't work that much on LabVIEW NXG, so I actually don't have that much visibility into its timelines. I can speak in generalities on that. This presentation, by the way, is going to be focused 100% on LabVIEW. There's nothing about LabVIEW and XG in this presentation. So just to set expectations ahead of time. Question?
Has the build API extended to include all the different types of builds you can do?
You're referring to like the internal app builder API?
Yeah.
Okay, so the question is, in case you guys didn't know, there is actually an internal API in LabVIEW to be able to interface with App Builder. So all the stuff that you can do building EXEs, DLLs, RTXEs, all that kind of stuff. There is an internal API in LabVIEW that allows you to programmatically do all that stuff. And the question was, has that been extended in any way? There were some gaps in that API a few years ago. The answer is largely no. The API still has some of the limitations from before, probably some of the ones that you encountered back then. Question?
So there's a couple of spots where I look at things and say, I wonder
So the question is, you look at an enum or a cluster in a LabVIEW API that's provided by National Instruments, and you say, that should be a type def. Why is that not a type def? And the answer is usually, I don't know, it probably should be a type def. We've gone through, we've actually fixed a few of those, like that sort of come up, some of the more egregious ones. With the design of LabVIEW NXG, we're paying very careful attention to that. You should see that a lot less in LabVIEW NXG, since, again, being built up from the ground up, we can say, hey, that thing that hasn't been a type def for 30 years in LabVIEW, let's go ahead and make it a type def in LabVIEW NXG. So there's no technical reason why a lot of those type defs, or a lot of those enums and clusters in our APIs are not type defs, even though they probably should be. That bothers me too. I'm a big fan of type defs. Got 5 minutes. For those of you just coming in, this is like the Reddit AMA, but it's not on Reddit and it's me. Ask me anything. The NIWeek AMA, how's that? Hey Sam, I tried to beat your score on Boggle downstairs. I could not do it. I'm second place right behind you. So. Nice job. That was amazing. I wish I could have seen. I actually needed my daughter's help to get the score I had, so I can't even imagine how fast your fingers were blazing. If y'all haven't played the Boggle game down on the next to the LabVIEW Lounge yet, it's pretty cool. If you're into that sort of thing, which I am. I like doing stuff fast. I am the quick draw guy after all. All right, any other questions? We still got a couple minutes. That's how we'll know when we're getting started. Right, you don't have to do it. Yeah, we still got 3 minutes. 4 minutes? Okay. Uh-oh, guys, my boss is here. My boss is here. I can't tell you all the secrets I was telling you before. Yeah. Okay. Any other questions? We got a full room. This is great. It's almost as if you guys wish you could implement your own LabVIEW features and not have to wait for LabVIEW RandD.
Raise your hand if you have a seat next to you, so we know where the open seats are. Okay, there's a bunch over there. That way you guys don't have to stand. There are some open seats I see in this corner. It looks like over there.
Hey, Oscar, if you're coming. Okay. All right, just a couple minutes. Any last minute questions for the LabVIEW RandD guy?
Excuse me.
Yes.
Have you studied the rotation and control of the front panel?
So you want to be able to rotate controls on the front panel.
You change the position,
Mm-hmm.
but what about the rotation?
I don't think you can change the rotation of a control in the front panel.
It's not there.
Yeah. That'd be pretty cool. You can rotate text, but you can't rotate a control. You guys just keep asking me about things I can't do. That's kind of making me feel inadequate. At least when I start this, it'll be about all the things you can do.
All right, I'll go ahead and do the quick introductions because I want to make sure Darren has his full hour because he always has great material. If this is your first time in room 15 or 16A or B, you are in a special track, whether or not you're aware of it. So hopefully you saw on your way in the little tag, so you can pick one up on your way out. CPAD, this is our special track by the LabVIEW Champions. We sponsor it. It's the Software Engineering, Processes, Architectures, and Design track. So over the next 3 days, in these 3 rooms, right along this back wall, and then on Thursday, also in Ballroom G, towards the end of the escalators in the corner, are advanced tracks, or advanced for intermediate, I guess, advanced users on LabVIEW topics that you'd be interested in hearing. Also on that back door on your way in all of these rooms is a sheet that Nancy printed out. You can search by the track in the app, of course, but this is a nice way, and it kind of also clearly delineates our mini tracks within tracks. Because like on Thursday, we have a whole separate section on DQMH. There's a bunch of those with Fabiola, and not even just her, but other people presenting on it in a row. We have continuous integration, user interfaces, so all these little sub-tracks within our big giant software track. We are also videotaping these sessions. And with permission of the presenters, we will be promoting them on, Nancy has these little links here on the LabVIEW Center of Excellence website. She will post links and stuff. So Nancy Henson will be doing all that. And with that, I'll introduce the world famous, he had to retire, fastest LabVIEW programmer, Darren Nattinger.
All right, thanks, Becky. How many of you guys are attending NIWeek for the first time? That's great. So my name's Darren Nattinger. I work in LabVIEW R&D at NI. I've been at NI for over 19 years. 16 and a half of those years have been in LabVIEW R&D. I am a G programmer. I have never written a line of C++ or C# code in my life. And my day job is to add features to LabVIEW. So the only way I can add features to LabVIEW is with G code. So I started thinking, wait a minute, there's a lot of other LabVIEW programmers up there that they also want to add features to LabVIEW that are not me. So that was my motivation for this presentation, is I wanted to put in front of your eyes every single possible way that you can extend the LabVIEW editor with LabVIEW code. So that is what we're going to be talking about today. But before we get started, get out your phone or your pen and write down / take a picture of this, because these slides are available at this link. One of the things I will often do when I give presentations is put in the slide like the keywords that you need to Google to go find something. There was entirely too much of that for this presentation. This presentation is full of actual clickable links. So in order to get those clickable links, you're going to need to download the presentation, and you need to go to bit.ly/dmatlbhooks to download these slides. So I'll leave this up for another second because I still see a few phones taking pictures. All right, the last one went down. Nope, wait, there's another one. All right, so go to this link, download the presentation. You can do it right now if you want to, and you can start clicking on the links as I'm presenting. If I start talking about something and you find it boring, but something earlier was interesting, you can go click on the links and sort of study it a little bit more. So in this presentation, I'm going to go through 3 sections. The first section is I'm going to talk about VI scripting. So in order to enhance the LabVIEW editor, you're going to need to know VI scripting. There are a lot of resources available for scripting, and I'm going to point out a lot of those in this presentation. Then, I'm going to talk about editor features that have hooks for scripting. The ones that are the most fleshed out are Quick Draw, right-click plugins, pull-down menu plugins, and VI Analyzer. But there's a whole lot more too, and those are in the miscellaneous section. And then, at the end of the presentation, I advertised this. If you read it in the NIWeek description, I said I'm going to tell you about every way to hook into the LabVIEW editor, and that is true. I'm going to. However, I'm also going to tell you don't ever do some of these things, and those are going to fall in the rusty nails section. All right, so if you are going to implement your own LabVIEW features, you got to know what VI scripting is. So we're going to spend the next 10 minutes or so talking about what scripting is. If you've never heard of VI scripting, it's actually very simple what it is. It's VI server. It's just got some more stuff. So with VI server, hopefully most of you are familiar with VI server. You get properties and methods on doing things with controls, with VIs. You can mess with things in the project if you want to. If you look at that screenshot there, we're getting a reference to a control in the front panel called myBoolean, and we are setting its visible property to false. So this is an example of something we might do with VI server, changing the appearance of something on the front panel, right? That's VI server. What's VI scripting? Hey, it actually looks really similar. It's properties and methods for controls and indicators, and VIs, and projects. A little plus there is because scripting actually opens up several more new properties for things. For example, numeric control on the front panel, you can change its visibility, like in that screenshot there. When you turn on scripting, you can also do things like change its representation. So you can change it from double to I32. That's an example of something that sort of gets opened up when you turn on scripting. Well, in addition to this stuff, the big kicker is that you can start messing with block diagram objects when you enable scripting. So the screenshot down at the bottom looks pretty similar to the one on the top, but instead of messing with a control in the front panel, we actually got a reference to a while loop, and we are adding a shift register to it. So you can see the way the code looks is very similar. You get references to things, you set properties, you read properties, you call methods. It's just that with scripting, now you can do it to stuff on your block diagram and additional stuff on your front panel. For those of you that have worked with scripting or VI server before and you're wondering what the heck is that blue VI there, it's a really, really useful blue VI. It's called tref_find_object_by_label. It's not in the palettes, it's not in Quick Draw, but it's really handy when you're doing scripting stuff because it's an easy way to grab a reference to something by its label and then do stuff with it. So if y'all have never heard of my Hidden Gems presentation, go to ni.com/hiddengems. I know the person at NI didn't give me URLs. It's pretty cool. So yeah, ni.com/hiddengems, and I have an entire presentation of basically all the really awesome VIs that are in VI lib that are not in Quick Draw for the palettes. And tref find object by label is one of them. It's actually going to appear multiple times in this presentation. So how do you turn on scripting? It used to be really hard. For the past 10 years, it's been really easy. You go into Tools, Options, VI Server, VI Scripting, and you can just click a couple of checkboxes there. It will open up a set of VIs and functions in the palettes and quick drop. It'll also start giving you some really useful information in your context help window. So when you start needing to know things about like the connector pane pattern of VIs, when you start needing to know which terminal index things are on a VI, that stuff magically appears in the context help window when you turn on VI scripting. Another thing that scripting gives you, so this is a very, very abbreviated VI server object hierarchy. Pretty much everything you're ever going to want to manipulate on the front panel inherits from a class called GObject. Once you start looking under GObject, you're going to see panels, panes, controls. Under control, you're going to see, tree control, string, numeric. Under numeric, you're going to see text string, named numeric. That's basically a hierarchy of things. When you turn on scripting, you still have all that stuff you see on the left, but now we've opened up a ton of classes that you see on the right. Now you can access diagram, wire, terminal, node, function, structure, and the hierarchy goes down from there. So in addition to the stuff on the previous slide that scripting turns on, it also turns on all of those different classes that you can see in the VI server object hierarchy. Are there any questions so far?
What's the best way to understand the whole hierarchy available to you and know which one's the appropriate one to use to get it to you?
So the question is, how do you understand this massive hierarchy? There's a lot of stuff in there. He's not a plant, I promise. There are multiple resources for learning the hierarchy of VI scripting. My favorite is the examples. So in the examples folder, if you are the type of person who likes to just kind of open up a folder and start browsing through VIs, take this approach. Open up the examples, we start going into details about things like the hierarchy and things like what it means to modify objects versus create new objects versus manipulate objects. And the examples are a very good place to start for that. If you are more the type of person who wants to follow a tutorial, sorry it's a little bit light colored there, but it's a link, so download the slides and you click it. We have a scripting tutorial that basically starts from the beginning and sort of guides you through all the things that you need to learn in order to be successful scripting. And another option for learning scripting is to browse feature code that actually uses scripting. So I'm going to go through a lot of examples in this presentation of features that use scripting. I've included a few in the slides just because they're easy to get to on disk. But the vast majority of the code in these folders is not password protected. So it is also a very good resource to dig through and start learning about scripting through the code that's actually doing the scripting in the editor. Did that answer your question? These are kind of the places you can get started to start learning that hierarchy.
Well, there's not like a document which says this is the hierarchy.
So, okay, so I guess I could have answered that as well. So if you actually just want to straight up see a list of the hierarchy of classes, yes, that actually is in the help, in the LabVIEW help. If you go into probably the VI server or the VI scripting topic, you will see like a tree-based list of links that kind of takes you through the entire hierarchy of GObject. Any other questions? All right, I'm going to do a demo. We are going to add a feature to LabVIEW right now. It should only take me about 7 minutes, but before I add the feature, we need to have a little bit of background, okay? So let's switch over to LabVIEW. So somebody gave me this VI. This is a VI that does some really simple stuff, and they told me, hey, I need you to add a feature. In this VI, I need you to go delete the log file when the code initializes so that we always start with a clean log file. That's what they told me to do. So okay, let's go to the diagram. It looks like a state machine. It's pretty cool. Let's go ahead and just drop a delete in the initialize case. And I happen to know that it's in ctemp. And I'm going to go ahead and add a comment to my code because I like to be a good LabVIEW programmer. Delete the log file. If it's not there, no biggie. All right, I'm done with the feature. I'm going to run the code. All right, so if there's one thing y'all need to know about me, it's that I'm the quick drop guy. If there's a second thing you need to know about me, it's that I hate automatic error handling. It is the worst feature of LabVIEW. They haven't fired me yet for saying that, so I'm going to keep saying it. I did not tell my code to pop up a dialog. Why is there a dialog on my screen right now? My face is starting to get red, I know, so I need to calm down. So I added that code, but I didn't realize that whoever gave me this VI had auto error handling turned on this VI. Fine. All right, well, let me continue. Let me go ahead and just test the code to see if everything works. Okay, wait, that's probably not good. There's an empty dialog. So not only did I add what was supposed to be a simple feature and show me that auto error handling is turned on, but also there's something else wrong with this VI. So now let me go to this VI and see if I can figure out why I just got that empty dialog. All right, well, let's switch over here and I see two more things that I hate, although not as bad as auto error handling. I see the terminal view on an icon down here in the bottom corner, which I hate. And then this next one is probably just me, because I don't think other people hate this as much as me. Look at that subdiagram label up there. Now, when you're reading a book, and you read a line in a text of a book, and you finish that line, what do? You go to the beginning of the second line and start reading, right? You don't go to the middle of the page to read the next line. So center justified text and subdiagram labels also bothers me. So here I've got a VI from somebody that has auto error handling turned on. It's got terminal view on icons. It's got subdiagram labels. And it's also got something else that I really hate.
Auto grow.
So you see that empty string constant right there? That's why I had that empty dialog, right? So I need to have a message in that dialog when you click the button, right? So how about we say it's do something, then go to user state 1, and now I'm actually really worried, you guys, because I don't know about y'all, but I like how this diagram looks right now. This fits on my screen. It looks great. There's some nice white space over here. And I thought, oh no, I'll bet you the person that gave me this VI has auto grow turned on everything. So now I'm really scared to click away from that string constant, but now I just have to because it's like watching a train wreck, right? So I click away, oh no, no! Auto grow's turned on. All right, so I've had enough. This VI has 4 things that I hate in it. I can spend 7 minutes adding a feature to LabVIEW to make all of this go away. And that's what we're going to do right now. We are going to write a quick drop keyboard shortcut called Make Darren Happy. Let's see. So let's do new and create a quick drop plugin template. And there's all this commentary. Gosh, who wrote all this? Oh yeah, it was probably me. All right, we'll get rid of all that because we don't need any of that. All right, so the first thing I'm going to do is I'm going to turn off auto error handling. Oh wait, actually the first thing I should probably do is save this thing, right? Make Darren happy. And then let's call this thing Make Darren. So if you ever do undo, I don't know why you would want to undo making me happy, but if you do, you want to make sure that that's what shows up in the undo stack. And oh yeah, we should probably make a description of this thing. So change a bunch of stuff in a VI that Darren hates. And we'll make the shortcut H. That way the H can stand for hate or happy. So whichever thing I'm thinking of at the time. All right, so now everything's saved. So the first thing we want to do is turn off auto error handling because it's the worst. So that is done. Now what we need to do is, let's see, how about that control terminal thing? I hate the control terminal thing. So let's go find all the control terminals in our VI. I happen to know the names of these classes. That actually helps me quite a bit. If you didn't know, you'd have to browse the list probably. All right, so we have found all of the control terminals. Let's go through each one of them and turn off icon view. All right, so icon view is turned off. All right, so we've done the auto error handling thing. We've done the icon view thing. What was another thing I hated? I hated auto grow on the structures. So let's go in here and say for all the structures, sorry the code's a little messy, kind of on a timeline here. So structure, now we want to turn off auto grow on structures, worst. Okay, we're almost done. Now the only thing we need to do is to change that subdiagram label thing. So now let's go in here. Now one of the things about scripting is that there's just a ton of little corner cases and idiosyncrasies that you have to know. And what I'm trying to do in this presentation is point out every single one of those whenever they happen. I'm also trying to program and talk at the same time, which is harder than it looks. Hey, look, I just made that bold. All right, so one of the things that, did y'all know that Control B, Control I, and Control U will bold, italicize, and underline text by default in LabVIEW 2018?
Woo!
Yeah, great. All right, so here is our subdiagram, label, justification. All right, we're almost done, you guys. Okay, we're gonna make it left. Now, one of the little idiosyncrasies I was talking about in scripting is that sometimes you have diagrams that don't have subdiagram labels, and that code would error out, so I'm just gonna skip the error. All right, so I think we've got everything here. Auto error handling turned off, terminal view set to false, auto structure set to false. What's that?
Do you have auto error Boolean up?
Oh, yes, we can delete that Boolean constant, everybody. Okay. All right, so the VI references are all going everywhere. Okay, so good, we're good. We're gonna make Darren happy. So, Control Space, Control H. Notice I did not have to restart LabVIEW. I think that was less than 7 minutes. And now we've got no more icon view. We've got no more subdiagram label justification. We've hopefully got no more auto grow. And when we run the code, we have no more auto error handling dialogues come up. So in less than 7 minutes, I just added a feature to LabVIEW. Now, what is that feature? Just real quick to remind you, whenever, oh, and here, we can even do undo. So let's go back to undo, make Darren happy. So now we're back to the grossness. But now all I have to do to implement, to make myself happy, to fix those 4 things on any VI I ever get for the rest of my life is press Control Space, Control H. So I just made a keyboard shortcut feature for myself in less than 7 minutes to improve my productivity, to make me happy, because when I ain't happy, ain't nobody happy. And I was able to do that with all features in LabVIEW. I didn't even have to restart LabVIEW. So the purpose of this demo is to show you guys, maybe you don't program quite as fast as me, and I understand that, but that was still pretty darn easy to actually throw that scripting code together. That wasn't rocket science. And now you guys know how you can just, even as just a quick thing, throw together a feature that will now help you in your productivity. Fabiola hates it when error wires sit on top of other wires on her diagram. She wrote a quick drop plugin that she opens a VI and presses Control Space, Control F to make Fabiola happy, I don't know. And all the error wires move behind every other wire on the diagram. That's something that I don't particularly care much about, but it was very important to Fabiola, and so she can just write that feature for herself. And now she's got a feature in LabVIEW that makes her happy. That's why I'm giving this presentation today, so that you guys can solve these problems on your own and not have to wait for me to implement them like a year from now, LabVIEw 2019.
And it is called the Fabiola pacifier.
The Fabiola pacifier. I didn't want to steal your wording here, so that's why this was make Darren happy. Any questions? Hopefully that demo solidified the value in what I'm going to present for the rest of this afternoon. Okay. All right, so when you start writing scripting code, particularly if you're generating code, a lot of the times you might write scripting code that's inspecting code, like stuff that the VI analyzer does. But if you're writing scripting code that is generating things, particularly generating things from scratch, there's a few best practices that I just wanted to spend a few minutes talking about. The first one is to try to figure out how to generate as few objects as possible. If at all possible, when you're generating code, try to start with templates that have as much already created for you. That VI that I showed where I turned off auto error handling and fixed the things, you saw that code started kind of getting stretchy, right? I mean, I was writing it fast, so I was kind of making a lot of space. But the thing about scripting code is that it starts to get really long. So if you can figure out ways to reduce the actual number of objects you have to create or the wires you have to create, then your code's going to be a lot more manageable, just because scripting takes a lot of nodes to get stuff done. If you're using templates, which hopefully you are, tref find object by label is a great tool to say, hey, give me that object, give me that object, give me that object, when you have things in your templates that are already labeled. If you're generating code that end users are going to see, it's really handy to have a note that just says, don't mess with the objects that have this label, because obviously if they do, then your scripting code's probably not going to work if you have to go and script in there again. So this is one where I diverge from what you're taught. So be careful on this one. There is a function called OpenVI-Object-Reference. If you have scripting enabled, you'll see it in the scripting palette. That function is worthless. Do not use it. Use TREF-FindObjectByLabel. The reason it's useless is because it doesn't look inside of nested objects. So if you've got an object sitting inside a case structure called add, and you call OpenVI-Object-Reference on the diagram and say, give me a reference to add, it's going to say, I don't know what add is. It's because it's sitting in a nested diagram. Well, that's worthless. You've got stuff sitting in nested diagrams all the time. Use TREF-FindObjectByLabel. That's going to look through all the nested stuff and give you the object that has the label that matches.
Darren,
Question?
can you use the TREF-FindObjectByLabel in the runtime, or is it only in development?
So the question is, does TREF-FindObjectByLabel work in a built exe? And the answer is no. That's a good point that I should bring up now. Anytime you see something blue in LabVIEW, that almost always indicates scripting, whether it's the built-in functions or whether it's an invoke node or a property node. If it's blue, that means it was turned on by scripting. Scripting stuff is not supported in the runtime engine. And there's reasons for that, but the main reason is almost all scripting stuff is done as part of the LabVIEW editor. You're adding features to the editor. So most of the time, that type of stuff just wouldn't be supported in a built exe. All right, there's another VI, traverse for GObjects. A lot of times I see people write scripting code where they read the controls property on the front panel to do stuff to controls, or they read the all objects property on the block diagram to do stuff to all objects. But again, those do not include nested objects. And you almost always, if you want to do something to the while loops on your diagram, you probably don't care if the while loop's sitting inside a case structure or not. You just want to reference the while loops. That's when you're going to use traverse for GObjects, because that doesn't care about nested things. All right. So I have a presentation I've given called Brainless LabVIEW. And you can go to that link right there and download it and watch a video recording of it. And one of the things I talk about in that presentation is that you do not have to close GObject references. We're all taught the best practice that we should close all references that we open. It's actually a total waste of time to close a GObject reference because LabVIEW is actually not going to close anything. All the GObject references in a VI are maintained until that VI goes idle or out of memory. So if you have like a reference to a panel and you close the reference to the panel, then you use the reference to the panel to do something, it totally works. So closing the panel reference was just a waste of time. So don't worry about closing GObject references. I have more details in the presentation about that. You definitely want to close VI references and application references and ActiveX references and hardware references. All the other references, you want to close those. But GObject, don't waste your time. You do not need to close those. All right. I've heard people complain that scripting is slow. Scripting is not slow. I've worked on a whole lot of scripting features over my many years in LabVIEW R&D. And when somebody says scripting is slow, what they really mean is VI load time is slow. There's some utility that is operating on a VI and they're complaining that the utility is slow. And we find out that 98% of the time it took to run the utility was actually opening the VI reference, and 2% was whatever scripting you were doing on that VI. So scripting is actually very fast. If you've got one of these massive spaghetti diagrams that you see in people's presentations sometimes, yes, parsing a diagram with thousands of wires in it will probably be slower than parsing a regular diagram. But if somebody says, Christian, come on man, vibrate. If somebody says scripting slow, what they probably mean is VI load time is slow. So don't like give up on scripting from the beginning because you've heard that it's slow. It's not true. All right, this one's kind of an esoteric one. When I talk about context, I'm referring to application instances. So if you've got a project with my computer and an RT target and an FPGA, every one of those targets is a different application instance. If you're writing a scripting tool that's doing something to things that are in different application instances, like you're opening a reference to something from my computer, but you're trying to mess with a VI that's under the RT context, you're not going to have an enjoyable experience. So whenever you're working on scripting stuff, make sure that when you do that OpenVI reference, you are using the proper application instance wired to the top input of OpenVI reference to make sure you're manipulating the VI in the context that owns that VI. Is that right? Question?
When you run pre-post deductions,
so the question is when the VI is like a pre-build VI or post-build VI, what context they run? I actually have no idea. All right, so there's something called the scripting Springboard. Norm Kirchner, if you guys know him.
There's a way that you can find out what application instance it's in. If you have your scroll bars turned on, it shows it in the bottom left-hand corner.
That's true. I guess you could show the front panel of the VI and see what app instance it's running in. I'm guessing it's the app builder context.
Yeah.
So anyway, sorry, to move on, scripting Springboard. If you guys know Norm Kirchner, he wrote this utility, and it's actually a pretty simple utility. It's kind of a way to just play with scripting. Like, what happens if I do this and I do this? It's a lot quicker to start with the Springboard than to start with your own like blank VI, open reference to blank VI, look at its diagram. Scripting Springboard takes care of a lot of that for you. It's also got some features built into it that are really cool. There's one called Smashy Smashy that I'm not going to tell you what it is, but it's really neat and you're going to like it, but you got to download the Scripting Springboard to try it first. All right, so now I'm going to talk about features in LabVIEW that have hooks that you can use all the scripting stuff to work on. The first one is quick drop plugins. So you probably saw me use several of these when I did my demo. It's pressing a control key while the quick drop window is open. Make Darren Happy was a quick drop control key plugin. Remove and rewire, if you guys ever use control space, control R, that's a quick drop keyboard shortcut. You're going to want to write these when you're doing something that's frequent and repetitive. For example, remove and rewire, we do several times a day. Create all controls or create all constants, we do several times a day. We've got documentation for writing your own at this link. There are 8 plugins that ship with 2018, including a new one called Reset to Origin. This is one that people have downloaded off of the forums for years, and we finally put it in LabVIEW. And basically all it is on your front panel, you've got it just the way you want with the controls in the right spot. Then like you double click on a terminal on the diagram and it like totally scrolls your front panel to a nasty spot. Control space, control O switches the scrolls the front panel, back to the origin so it's in the right spot that you originally wanted it. There are 50 plugins available on NI.com. NI.com/quickdrop. Remember, I know how to get these URLs. So that's where the enthusiast group is, and that's where you can download all these custom plugins. So in this presentation, I wanted to show an example of scripting code in each of the features that I'm talking about. And here's an example of the wire all terminal. So this is when you click a function, press Control Space, Control D, and all the controls and indicators get created for you, or Control Shift D makes all the constants. So that's what the scripting code looks like. You can see we've got, so this for loop is going to run for all the terminals on the node. We see if the terminal's not wired. Then, based on if it is a source or a sink, in the inner case structure there, we will either create a control or we'll create an indicator. Now, one of the things about scripting is that there's a million little caveats and corner cases, and in every one of these screenshots, I'm going to point one out just to kind of show you the weird stuff you have to deal with when you're in scripting. But it's fun, right? A hidden terminal. What the heck is a hidden terminal? You can see I'm reading the isHidden property of a terminal and then not doing stuff based on that. Well, a hidden terminal is something that you guys are never going to see unless you're doing scripting. You see the ears on the time loop? Those ears are connected to the time loop itself by something called a hidden terminal. You don't ever see it, you don't ever interact with it, but I'm pretty sure you don't want my quick drop plugin messing with them whenever you're using Control Space, Control D, right? So that's an example of something that we just kind of have to know about when we work on scripting stuff. Hidden terminals. There will be more of these little weird things. All right, so right-click plugins. Look at that picture up there. We've got a list box with a bunch of text in it. And when I learned LabVIEW in January of 1999, and I learned about a list box, I played with the list box, and then I right-clicked on it, and I wanted to delete all the things in the list box, and I couldn't, because that was not a feature in LabVIEW 5.0. In LabVIEW 2015, it was also not a feature. So I had waited for many, many years, 16 years, to be able to delete everything in a list box, and I couldn't. Well, my esteemed colleague, Stephen Loftus-Mercer in LabVIEW RandD, all of you guys should know who he is, added a feature to LabVIEW 2015 to allow me and any of you to write G-code to add right-click entries into the LabVIEW editor. You know what the first thing I did was? I wrote that in 15 minutes. So you can right-click on a list box in LabVIEW 2015, and now you've got a delete all rows entry. So in LabVIEW 2015 and later, you can write G-code to add things to the right-click menus. This is what you're going to want to do when you have a context-sensitive operation. Remember the quick drop plugin? It wouldn't have made sense for me to write a quick drop plugin to empty the list box, right? Why would I want a keyboard shortcut that could operate on anything in the editor when it only pertains to a list box? So right-click plugins make more sense when you want to do something that's context-sensitive. The LabVIEW help talks about how to make them. There are 16 plugins in 2018 and later, including several new ones. I won't go through what they are right now. There are over 60 available at ni.com/lvmenus. So that's the enthusiast group for people who want to write right-click plugins. All right, so here's some more sample code. This is a right-click plugin where you can right-click on an array terminal and create a scalar constant. Christian wanted this back in the day. I know. You posted the thing on the Idea Exchange, I remember that. So yeah, like let's say you have an add primitive and it's got an array wired to the top input. Well, if you right-click and do create constant on the bottom input, you're going to get an array constant. What if you wanted a scalar constant? This is a right-click plugin that does this. I'm not going to go into all the details. The top picture shows how we generate the menu that you see. The bottom picture is the actual scripting code that creates the thing. Now, can anybody in this room tell me what that function is? I need the official name, guys. Clean up block diagram. I thought you said that, but that was awesome. No, this is the request deallocation function. So this is another one of those weird caveat corner cases that I like to bring up just to kind of tell you how interesting and fun scripting is. If you ever read the data type property of a terminal or of a control, and that variant that comes out of there has LabVIEW class information, and you're doing that operation across different application instances, like I talked about before, LabVIEW will crash. May not be now, may not be in an hour, but it will someday. And the way we prevent that is by dropping request deallocation. So anytime you're ever reading the data type property, make sure to drop request deallocation nearby just in case. See, scripting is fun. All right, so next, pull-down menu plugins. Did you guys know that you can write VIs that show up in the pull-down menus in the LabVIEW editor? You can have them show up in the tools menu, the file menu, or the help menu. The ones that I have in the red box are actually all G code. So every one of those features that you see right there is a VI sitting on disk somewhere. We have documentation for writing your own ones of these. These are more useful when you want to do something on an environmental basis. So you want to launch a tool, or you want to perform an action like for the specific VI whose panel or diagram is open right now. So not more like the context-sensitive several times use cases we saw before. All right, so here is some sample code for a pull-down menu option that will do Explore. So if you have a VI open and you do Tools Explore, it will actually open a Windows Explorer window and have the file selected for you wherever it is on disk. So this is the scripting code that does that. So what's that little VI right there? That is the VI you have to run if you want to know who launched you. So when you're launched from a tools pull down, that VI tells you the app instance and the name of the VI that it was launched from. Does anybody know why I have a 2 wired to the OpenVI reference?
Templates?
Templates, that's right. If you have a template, like a .vit file open, and you do OpenVI reference without the 2 wired, it actually creates a new instance of that template. Well, if you do that, then you've got an untitled instance, and it's not on disk, and the Explorer plugin won't work. So we need to open a reference to the actual template itself, not to a new instance of the template. That's what the 2 does. And then we have to do FP close at the end of any of these things because for some oddball reason, when the pull-down menu entry stuff was added to LabVIEW 20 years ago or whatever, they always show the panel of the thing that you launched from the tools menu. So we need to make sure to hide the panel once our plugin is done. All right, so now I'm going to talk about VI analyzer tests. In, let's see, 45 minutes, I'm actually going to be talking about the VI analyzer again, 2 rooms over. But right now, I'm just going to mention that VI analyzer allows you to have code that inspects or modifies other VIs. Most people don't realize that there's nothing stopping you from having a VI analyzer test that will actually modify code. And the reason that's useful is if you have to do bulk operations on VIs. Remember my Make Darren Happy VI, which I can do on anything. Like somebody gives me a VI, I see stuff I don't like, I press Control Space Control H. What if somebody gave me a project of 500 VIs and every single one of them has autogrow turned on? Well, hopefully I'm not going to quit my job, assuming I still work in my job. I'm probably going to write a VI analyzer test that will, in bulk, go through that entire application and turn off autogrow and turn off icon view and all that stuff that I hate. So documentation exists for writing your own. There are 92 tests that ship with the VI Analyzer Toolkit. There's some packaging questions that people sometimes have about the VI Analyzer. It is a toolkit in terms of the tests that you get. There's 92 tests that analyze things like style and block diagram problems and things like that. The toolkit itself is a product, just like other toolkits that NI has. Part of LV Pro, part of DevSuite. Required if you want to make new tests. but then the VI Analyzer like engine itself that actually performs the analysis, that's all part of LabVIEW core. So if you don't have VI Analyzer toolkit installed, but somebody gives you a VI Analyzer test, you can still run it. The community at ni.com/VI Analyzer has over 50 community tests available for download. And there's a presentation I gave that sort of introduces everything about VI Analyzer at that link there. So speaking of icon view, here's a VI Analyzer test that will go in and turn off icon view on every control terminal in the VI. And if it changed anything, we'll save the VI. One thing you really need to be careful about is that since this is a bulk processing tool, you need to make sure your scripting's good and you need to make sure your code's backed up. Because when you point this at a folder and say, run this test, it is going to modify all of your code. And if your source is saved in 2016 and you accidentally opened this in 2017 and ran this tool, you have now saved over all of your source to 2017, which you may not have wanted to do. So make sure you back up your code before doing things like this type of bulk processing. All right, so I just talked about 4 big features that are extendable by you. The first is quick drop plugins. Control space controls something. That is for a repetitive action that you perform multiple times a day. Remove and rewire, quick drop insert, quick drop replace, those types of features. Right-click menus, those are going to be for context-sensitive things. If you want to do something specific to a list box, or something specific to a shift register, or something specific to a string constant, then you're going to make that a right-click plugin because it's going to be sensitive to only that type of object. There's one exception to this. I create constants, controls, and indicators dozens of times a day. And that is something that I do that is more specific than the selection order. Like if I click on an add function, I can select that add function, but I can't click on one of the individual terminals of the add function. But I can right-click on one of the individual terminals of the add function. So what I have is I actually have a right-click plugin that takes constant, control, and indicator and just moves them to the very top of my right-click menu list. So now instead of having to go to that create pull right, which I know all you guys hate having to do every time you have to create a constant, I've pulled them all up to the very top of the list. Now this is my own personal plugin. It is available for download at ni.com/LabViewMenus, and we're talking about implementing this in Core LabVIEW in a future release. But for now, this is one of those features that you would have to add yourself because we haven't done it in LabVIEW RandD yet. But that's an exception with right-click menus. Is that I actually use that right-click plugin more than I use probably any other feature in LabVIEW, the one that just pulls them up to the top because I create constants, controls, and indicators so often. All right, pull-down menus, those are going to be for whenever you need to do something on the environment, like launch a tool, or something on the whole VI itself, like the Explorer tool. In the VI Analyzer, you're going to write tests for that whenever you want to perform bulk operations, whether it's just code inspection or it's modifying code as well. Question?
So, when you've gone through and created all these different types of plugins and made your environment in a way you want it, what's the best method you found for taking those tools and deploying them to other developers?
Excellent, good question. So the question is, I have my LabVIEW just how I want it. How can other developers on my team get their LabVIEW just the way they want it to? There's 2 ways. The low investment way is that most of these plugins that you see here, you can actually install into your LabVIEW data folder. They don't actually go into the LabVIEW specific folder. So if you've got several LabVIEWs on your machine and you want one plugin to be available for all of them, you can dump that in a certain spot in your LabVIEW data folder and it will be available for everything. So if you want like the sort of the low investment way, you can say, here's the plugins for quick drop and right-click menus and VI Analyzer. Here's a LabVIEW data folder, drop, now you've got them. This developer has them in all of his LabVIEWs. The other way that's a little bit of a bigger investment is to make VI packages. I've seen people be very successful distributing this type of stuff as VI packages, because then you just tell every developer run this and it'll install stuff in the right spots.
Darren,
Question?
The LabVIEW data folder thing?
Yes.
How does it deal with versions?
So the question is, how does the LabVIEW data folder trick that I just talked about deal with versions? Just like you would expect, if you drop a plugin that's saved in 2016, it'll work in 2016, 2017, or 2018. It won't work in 2015.
Is there a penalty for like breaking a line? I guess it's
Answered your own question. All right, so miscellaneous hooks, I'm not going to go into detail on all of these. You are probably going to say, wow, I can't believe that. And you're going to want to go click the link in the presentation when you go download it. You can write your own icon editor. National Instruments is written in icon editor. There's some good things about it. There's some bad things about it. If you don't like it, you can install your own. There are actually multiple icon editors available for download on ni.com that are not NI's. Also, the source code for our icon editor is available at this link as well. So if you like ours, but there's one thing you want to change, get the source code and make the change yourself. You can customize the behavior of edit, create, sub-VI. Right now, it does a pretty good job of doing things like getting the front panel arranged, putting the air terminals in the bottom, labeling things right, but you can customize that behavior however you want. You can even, so there's multiple levels of customization. You could let us do all the scripting for you and then add on your own scripting at the end, or you can just completely overwrite how we do edit, create, sub-VI and do it yourself. You can write your own Bookmark Manager. So the Bookmark Manager is a great code review tool. I love it. Whenever I go to somebody's desk, I expect that they have added bookmarks in the code for the parts that we need to review for a code review session. You can customize this. Somebody has uploaded a Bookmark Manager, I think it was David actually, that will show you an image of the diagram where the bookmark is. You can add your own project templates and sample projects. So if your team has a starting point for your applications that your team uses, add it to the Create Project Dialog. And now that's another thing you can create. Just like the NI State Machine and Active Framework and all that stuff, you can also have your company's stuff show up in that list as well. And for those of you channels fans out there, you can actually come up with your own custom channel wire types. And don't even get me started on that because I've never done it, but there's a link that you can start at to get started on doing those. All right, if you want to add your own content to the File New dialog, it's pretty simple. Add a folder that has your templates, add images that are of the front panel or block diagram of those templates, and put them in the right place and name them the right thing. And now they're going to show up. Check it out. I made a folder called DNAT's templates. And I've got scripting operation templates that show up in the new dialog, and you can see a pretty little picture of it next to it. It's very easy to plug stuff into the File New dialog. If you want to customize the way LabVIEW class accessors are created whenever you make them, there are several ways to do that. If you want to add your own scripting after we've created the accessors, that is possible. If you want to change the name, if you want to change what's in the VI, so if you don't like that we make them 4224 and you want to make them 5335, you can change that. You can change where stuff appears on them. If you don't like the fact that there's an error case structure on the accessor, you can go change the template or change the scripting so that that's gone. Some people don't like how accessors are called read and write. Some people think that those terms feel more like hardware terms, and they would prefer their accessors to be called get and set. You can customize that so that your accessors are created with that name instead. Or if you've got other words you want to use instead of those. Basically, just dig around in the LB class library folder and see what you can find. Most of it is not password protected. And the things that I mentioned here are good starting points, but there's several other things you can customize as well. All right, I wanted to talk about custom probes real quick. Sometimes people don't really think of that as sort of customizing the editor, but I kind of think it is. There's a help topic about how to make your own custom probes. LabVIEW actually ships with some great custom probes. Some of the waveform ones are pretty neat. The picture one is really cool. I've got a set of custom probes I wrote called history probes. I actually wrote them LabVIEW 7.0, I think. They've been downloaded thousands of times off of ni.com. There's a screenshot there. You can basically see the history of every value that's gone through a wire. It's really handy for things like queued message handlers, where you can stick a history probe on that string wire and see all the messages that came across and figure out, oh crud, I got the order mixed up on these. And so, but I have them for strings, numerics, paths, booleans. There's some statistics probes. There's a link there, and those are pretty neat. If you have LabVIEW classes, you can actually define what the probe looks like whenever somebody creates a probe off of your LabVIEW class wire. But there's also a little-known feature in LabVIEW 2016 and later called Data Agnostic Smart Probes. What the heck does that mean? Well, you guys may not know this, but whenever you write a custom probe, it is linked to a specific data type. So if you make an awesome probe that's for double, like a double floating point wire, and somebody right-clicks on a single wire, your awesome probe's not going to show up. So you're going to have to make a single probe as well, and then an extended probe, and then a U32 and an I16. Now you've made like 15 probes for that one cool thing you made. Well, we have a probe type called Data Agnostic Smart Probes that you can stick on any wire, and it doesn't care what the data type is. And we've actually come up with a couple of really cool use cases for these things. The screenshot there is a timing probe. That's one of the highest kudoed ideas on the ID Exchange. People want a timing probe. They want to stick a probe here, they want to stick a probe here, and they want to see how long it took to execute the code in between. And we have a data agnostic smart probe that can do that now, that you can download at that Nugget Post link. We also have another one. There's another idea on the ID Exchange. People want to conditionally turn on and off execution highlighting. So starting here, turn on the light bulb. Starting here, turn off the light bulb. We made a data agnostic smart probe for that as well, and that's also available to download at the link. There's question marks here because I don't know what else people are going to think of to do with these things, but I think they're going to be pretty cool, whatever they are. I thought I saw a hand in the back. Yes?
I've worked with the data agnostic smart probes, and my one limitation was it doesn't work on RT since the X controls. Is there any plans to make that rework it so that it works without X controls?
So the question is, these data agnostic smart probes, the one that you see on the screenshot here, uses an X control in the probe itself, and that probe cannot work on RT because you cannot have an X control in your probe on RT. I don't know. If we make this into a product, we'll probably revisit that. There are specific reasons we made an X control out of that. I don't know if we can get around those reasons. It's good to hear somebody's been playing with it though. All right, how many of you have seen Home Alone? Raise your hand if you've seen the movie Home Alone. All right. I love Home Alone. I've actually got 4 boys in addition to my daughter, and my 4 boys all love that movie. I loved that movie when I was a kid. So Harry and Marv are the robbers, and they approach the McAllister home with visions of great riches. They know that the house is loaded with just jewelry and all sorts of great stuff that they can steal. So they come up to the house. We all know what happens. They get their headsets on fire. They get a paint can to the face. He steps on a nail. If somebody had come up to them before they entered the house and said, "Hey guys, I know there's a lot of cool stuff in this house, but before you go in, I'm going to tell you that if you go in there, an 8-year-old kid is going to cause you to feel immense amount of pain, and then you're going to get arrested, and you're not even going to give you the cool stuff." Okay, y'all are the burglars. I am that person that just warns you. And all of the treasures in the house are what I'm about to talk about. I'm not going to give you any Google search terms on any of this stuff because I don't think y'all should be using any of this stuff. However, I advertise this presentation as I'm going to tell you about everything, so I am telling you about everything. But don't use the stuff I'm about to talk about.
Allow you the 8-year-old?
I think what I'm doing right now is incredibly mature.
Okay.
There are VIs called callback VIs. They start with the name LV_. They live in the resource folder. You can do some pretty interesting things with these VIs. What if you had a junior developer on your team and he spent the day writing LabVIEW code, and at the end of the day, he pressed Control-Q or File Exit to quit LabVIEw, and a dialog popped up and said, "You haven't written enough VIs for the day. Please continue working." You can actually do that with the callback VIs. You can override several pieces of LabVIEW like quitting or the about dialog or Control-N to make a new VI. Tons of ways to override that stuff. I don't think you should. And the reason is because this technology is 25 years old probably, and it hasn't been touched since it was added to LabVIEW. That includes when LabVIEW projects were added to LabVIEW. So this stuff far predates projects. So if you wrote a plugin for Control-N that made a new VI that had error terminals on the bottom and your company's logo on the top every time you press Control-N, that'd be pretty cool, right? Like that would probably help your team save some time. But if you did that inside of a project, you'd probably want that new VI to be added to that project, right? Can't do it. There's ways in VI Server to get a reference to the active project. Those ways actually don't work in these VIs. Like they just straight up return errors. So don't use these VIs because they haven't been touched since before projects existed, and I guarantee you're going to hit a roadblock with projects before you get too far. Avoid project providers. Project providers are a way to extend the project environment itself with G-code. So those features that I have red boxes around, those are actually G-code. If you do a new actor, that runs G-code to script a new actor. All the source code control stuff for checking out files, showing diffs, all that stuff, that is G-code that does that. The VI Analyzer actually has a project provider where you can right-click and analyze stuff. If you look in that screenshot up there and you see those little overlays, the little white squares on my code that I don't have checked out from Perforce, that is added by a project provider. The project providers can do some interesting things in the project window by adding features to the toolbar, to the right-click menus, to the icon overlays. Project providers are very, very difficult to work with. It's true that they're all G-code. However, there's so much like weird, fragile, delicate stuff inside of LabVIEW that won't work right if your project provider does just the wrong thing, that I cannot recommend people use them outside of National Instruments. I actually have a bug report assigned to me that I need to fix in 2019 related to one of these project providers. You know what the fix is going to be? I'm going to have to go through an entire hierarchy of VIs, look for any OpenVI reference, property node, or invoke node, right-click on it, and pick a hidden secret checkbox option in the right-click menu that y'all don't have that I do, just to work around this stupid crash. I'm going to have to do that because it's just a weird thing about project providers. So y'all don't even have that right-click menu thing. Y'all can't fix that crash when you get it, so don't try to write your own project providers.
You can fix that in 7 minutes.
That right-click menu option doesn't have a scripting thing, so I'm actually going to have to literally right-click on all of those things.
You're not
All right.
an intern?
The next one is, he probably missed one. The next one is Xnodes. If you've ever heard of Xnodes, an Xnode is a way to use G-code to define a block diagram object. All 3 of the objects you see on the screen are Xnodes. And you can already make your own block diagram objects. You can make sub-VIs, right? Well, Xnodes let you do things that you can't do with sub-VIs. They can allow you to make a growable node, for example. The match regular expression is a growable node. They can allow you to define hotspots on the node that you can click and operate on. For example, in the error ring, you can click on the red X to switch it to a warning. You can click on the little call chain symbol to turn off the call chain. They also allow you to define some data type behavior that you can't define with a sub-VI. Like if this type of wire is wired here, then change this terminal to another type or something like that. Xnodes are, I mean, they have some documentation issues. They have a lot of corner cases. A lot of the features of Xnodes are actually hidden behind licensing, and you have to do some rather unscrupulous hacks with LabVIEW to be able to gain access to all of those features. All right, you guys, some of you are not going to like the next slide. I think y'all need to avoid X controls. So X controls are a fully supported feature of LabVIEW. They're fully documented. If you have an issue with an X control and you call National Instruments, the AEs are obliged to help you. So X controls, in case you don't know, they allow you to write G-code that defines edit time behavior of front panel objects. For example, we've got that thermometer there. That's an X control. See how it's a thermometer, but it also has a checkbox underneath it? You can click the checkbox and it'll change the temperature between Fahrenheit and Celsius. You can add right-click menus, you can add properties and methods, and all of that is defined by G-code. The problem with X controls, the reason I cannot in good conscience recommend people use them, is I've seen too many cases, I know some people in this room have seen these cases as well, where there's a project being worked on, awesome X controls have been found and have been used, and as time goes on and the project gets more complex, something happens, there's a bug with X controls, and everything gets messed up. I mean, internal errors of LabVIEW, possibly crashes, possibly corruptions of files. When those things get reported to NI, and when we can reproduce them, we fix those issues. It's not like we just say, screw you. I mean, we actually do fix the issues, but the problem is I don't want to be in the position where I've spent all this time and invested in having a lot of my UI built around this X control that's really awesome, only to hit one of these performance or stability issues. So I've seen this happen enough times that I recommend people do not use X controls, because as cool as they are and as cool as that edit time behavior you get is, you will probably run into one of these issues. Another reason is that, as we mentioned before the presentation started, X controls are never going to migrate to LabVIEW and XG. So if you spend a lot of time working on an X control, you're going to have to start over if you end up porting that application to NIWeek. So that's my thing about X controls. Sorry if I offended anybody, but I really don't think we should be using them. Question?
Does this exclude downloaded or third-party X controls that have been vetted and checked?
So the question is, what about third-party X controls that are like in the tools network, that NI has verified and whatever? I'm speaking for myself here. I'm not speaking for National Instruments. I would not use those because I do not trust X controls. Yeah, so that data agnostic smart probe I showed has an X control on its front panel. I didn't write that, somebody else did. If we end up shipping that as a feature, I'm probably going to try to figure out a way to not have to have that use an X control. Quentin, would you like to give a really quick plug?
Can I do a plug?
1 minute. Do it.
So in my presentation on Thursday at 11 o'clock, I'll give some more reasons why you don't want to use X controls, and I'll give you an option to do instead of an X control. And not that I know where NXG is going, but it's more likely to be portable than obviously what X controls are.
Cool.
So Thursday 11 o'clock, you can learn more about that. So.
Any other questions on what I've said so far? All right, while we're giving plugs, LabVIEW RandD would like y'all's feedback. We're doing some research right now on G-based system design. I've actually prototyped some things for Jeff K that involve scripting, that involve the use case where you want to do a whiteboard sketch of what your application is going to behave like. But instead of using a whiteboard, why don't you just use a LabVIEW block diagram? So we're doing research into how you can have a block diagram show your whiteboard sketch. And obviously a block diagram ultimately is going to have your functioning G code. And you can just kind of stay on the LabVIEW block diagram that whole time. After my presentation, I have to leave because I'm giving another presentation. But Jakob, who's right here in the bright red shirt, is going to stick around up here. And if y'all have any feedback or want to give him your contact information or anything about helping us brainstorm this type of whiteboard sketch to functioning G design, he would love to talk to you guys. That is it. Please follow Scripting Ninja on Twitter. It's not me, it's someone else. I'm not the Scripting Ninja. But Scripting Ninja has a lot of interesting things to say about scripting. And you should follow him. Because, yeah, and he posts very beautiful, he or she posts very beautiful pictures. All right, if you didn't get it before, bit.ly, ly, dnet, lb hooks. I cannot stick around for questions. I have to go to my other presentation. Thank you, everybody.